Today we're going to talk about parametric surface area. So if we've got a smooth curve C that's given by the functions x equals f of t and y equals g of t on some interval from a to b, and we know that C does not intersect itself, then we can get the area of the lateral surface, or the surface area, of a revolution about the coordinate axis with the following two equations. So for revolving around the x-axis, we've got that s equals 2 pi times the integral from a to b of g sub t square root of dx dt squared plus dy dt squared dt. And then about the y-axis, the only thing that changes is instead of g of t, it's going to be f of t. And for both of these, that function, either x or y, do have to be positive values or 0. So we've got an example that says a wedge of an orange is formed by rotating the parametric curve x equals 4 cosine t, y equals 4 sine t over the interval from 0 to pi over 3 about the x-axis. We want to find the total surface area of the orange. So since we're going about the x-axis, we are going to use that top equation. And so it uses g of t, which is the y equation. So it's going to be s equals 2 pi times the integral from 0 to 3 pi over 3 of g sub t, which is 4 sine t, square root of the derivative of x dt. So if we've got dx dt is going to be the derivative of x, so it's going to be negative 4 sine of t. So it's going to be the derivative of x squared, so negative 4 sine t squared, plus the derivative of y, which is going to be 4 cosine of t. So then we've got that squared dt. So we can simplify this a little bit. I'm going to bring the 4 out, so it becomes 8 pi over the integral from 0 to pi over 3 of the square root of sine of t times the square root of 16 sine squared t plus 16 cosine squared t dt. And just like the other day, we can factor out the 16. So we get 8 pi integral from 0 to pi over 3 of sine of t square root of 16 times sine squared of t plus cosine squared of t dt. Sine squared plus cosine squared is going to give us just 1. So really this is sine of t times the square root of 16. So it's 8 pi integral from 0 to pi over 3 of sine of t square root of 16. And the square root of 16 is just 4, so we can bring that out in front with the 8. So it's going to be 32 pi integral of 0 to pi over 3 of sine of t dt. So then we can integrate. So this is going to be 32 pi times cosine of t negative cosine of t evaluated from 0 to pi over 3. So then we're going to plug in pi over 3 and 0. And I did move the negative just out with the 32. So it's going to be negative 32 pi times cosine of pi over 3 minus cosine of 0, or negative 32 pi times cosine is the x value on the unit circle, so that's going to be 1/2 minus 1. So it's negative half times negative 32 pi, which is just 16 pi. So the surface area of the orange is going to be 16 pi. Next example we're going to look at, it says find the area of the surface area generated by rotating the curve about the x-axis and the y-axis. So the first thing we have to do is find dx dt and dy dt. So dx dt is going to be 1. dy dt is going to be negative 4. So then we have, if we're looking for rotated about the x-axis, it's going to be 2 pi s equals 2 pi, the integral from 0 to 2 of our y function, which is 8 minus 4t, times the square root of dx dt, which is 1 squared, plus dy dt, which is negative 4 squared, that's dt, which is going to be equal to 2 pi times the integral from 0 to 2 of 8 minus 4t square root of 1 plus 16, which is 17, dt. I am going to move the root 17 out, so it's going to be 2 pi times root 17, integral of 0 to 2 of 8 minus 4t dt. So then we can integrate. We get 2 pi root 17 times 8t minus, it's going to be t squared, and we're going to end up dividing by 2, so it's really just 2t squared instead of 4 over 2, evaluated from 0 to 2. So then we've got to plug in 2 and 0, so it's going to be 2 pi root 17 times 8 times 2 minus 2 times 2 squared. And then if we plug in 0, it's going to be minus 0 because both functions have a t in it. So then we can simplify this, and we get 2 pi root 17 times 16 minus 8. So this is going to be 8 times 2, so 16 pi root 17. Or we could rewrite this so that the pi is on the end, which it looks a little bit better. So it's 16 root 17 pi. Similarly, we can find it revolving around the y-axis. The biggest difference is instead of plugging the g of x or the y function in, we're going to plug the x function in. So it's going to be s equals 2 pi times the integral from 0 to 2 of t square root of that 1 squared plus negative 4 squared dt, which is going to be 2 pi integral from 0 to 2 of t root 17 dt. And again, the root 17 can come out, so we get 2 pi root 17 equals, or times the integral of 0 to 2 of t dt. So if we integrate that, we get 2 pi times root 17 of t squared over 2 evaluated from 0 to 2. If we go ahead and plug in the 2 and the 0, we get 2 pi root 17 times 2 squared over 2 minus 0. 2 squared over 2 is just going to be 2, minus 0 is still 2. So this ends up being 4 root 17 pi.